Hi guys, welcome to the explanation for PT 41 Game 3. This is a pretty tough one because it's got some biconditionals. So if you came here from the lesson on biconditionals, take a close look at how we handle these. You can put them right in your chains just like any other in-out game. So we're still using the two chains method, building two super simple chains that can make things really easy to solve the rest of the game quickly. Okay, so here you've got these two groups, F and I. However, like any time where we just have two groups and no other place you can put the variables, I think it's the best strategy to translate this into an in and out game, which is a framework that you're going to be more used to. It's just a more common game, so it's way easier to... So say you have a rule that says G is in F, then H is in I. Then the contrapositive of that is going to be H is in F, then G is in I. That just gets harder to work with when you start chaining things together. So it's better to say, okay, let's make the F group the in group, and then we'll just call that in, just like that. And then I would be the out group, and we'll just label that like we normally do for things that are out with a strike across them. Contrapositive, H in F, then G out, i.e. in I. Doing that translation generally makes it much easier for people to work with, especially when we start chaining all these rules together. Okay, so what do we have going on here? We've got our 7 people. And for our first rule, if Guzman is on the finance committee, so in, then Hawking is in incentives, so out. And then I'm going to set up a space where I'm going to chain all these rules together. So as usual with the two chains method, I put one rule up here, and then it's contrapositive down here. Okay, next rule is that if LEP serves on F, so LEP in, then M and W are out. So M and W both out, i.e. they're in incentives. We can't add that yet. Whenever you can't add it to the chain, make sure you circle it so you don't forget it. And now this next rule is a biconditional. It's saying Wharton always serves on a different committee from the one on which Zoo serves. If you don't have biconditionals down, make sure you go back and check out the lesson on those. How we're going to do this is if W, then not Z, right? And that arrow works both ways. So say you see Z in the out group, that's going to tell you that W's got to be in the in group. If W is in the in group here, then that's going to kick Z out. These biconditionals are great because they just give you a ton of information. Anytime you know about one of the two, then you know where the other one is. Say you know where Z is, you know W goes in the other side. And then always make sure to get the contrapositive of that as well. Z, then not W. And that, again, works both ways. Again, we can't put this in yet, so circle it. Doesn't link up with anything. Next rule is the same, but for U, they can't be together. So U, then not G. That works both ways. And then G, then not U. And that works both ways. Finally, here's something we can link up. And remember, these are fully reversible. So unlike normal rules, you can just switch them around without negating. So we can just put that right here, not U, then G, right? Add it to the chain. This one, flip it around again, not G, then U, and that goes both ways. Okay, last rule here is Z, then H. If Z's in, then H is in as well. We can put that rule straight in here, and then it's contrapositive, not H, then not Z, right up here. And now let's make sure we add the rules that we didn't add before. Okay, now we can add this one, not Z, then W, and that goes both ways. And then down here, not W, then Z, and that goes both ways. So we've taken care of that one. Now we just need to get this one in. I'm going to try and make a little more room here. L, then not M, and not U. And then the flip of that, the contrapositive, is going to be U or M, then not L. So now we've got everything taken care of. We've got a nice long chain. It's going to be much easier to make inferences quickly. So at this point, you can just get rid of all these because they're all thrown in there. One last thing I want to note with biconditionals, when you get a biconditional that kicks two things into either group, well, we know they can never be together, right? So in an in-out game, one of these spots on this side is going to be G or U. One's going to be G or U on the outside, right? And then same thing with the WZ rule here. We're going to see Z or W on this side in just one spot, and then Z or W right here. And this can help us check orders much faster. You could also conceivably build scenarios around here. I chose not to, but you can start with all the possibilities with these 4 variables and build scenarios from that. I didn't think it was necessary because you can solve this game very quickly from this point with your chains. Okay, for 13, which one of the following could be a complete, accurate list of those on the finance committee? So you're just checking this against your chains here. So can we have G, H, M, and W on the inside, finance? Well, if G's in, then H is out. So this violates that rule right there. We can kick A out. How about G, L, and Z? So if we have G in, then that kicks H out, which then means Z is out as well. So this is gone. For C, we have H, M, and Z. The issue with this is it doesn't have one of G or W, right? You can see that here. You need to have G or W on this side. How about Hawking, Upchurch, Wharton, and Zoo? We see W and Z, they can never be together. So that's violating that, and we're left with E as the only possible right answer by elimination. Okay, for 14, we need a pair who can't both be out. So it's like not Guzman and not Hawking, and we're looking for one where that's going to kick the other one in. One being out is going to kick the other one in, so they can't both be out. You don't see that with G and H. You know, if G is out, it doesn't kick H in. If H is out, it doesn't kick G in. You know, you can't go backwards here, so I'm just not worried about that. I'm looking for one that obviously can't be in together. So how about Guzman and Wharton both out? Again, same thing. If I see Guzman out, it doesn't connect anywhere with kicking W in. And same with vice versa. W out actually ends up kicking G out as well. So now how about Hawking and Wharton both out? Well, if Hawking's out right here, that kicks Z out and then kicks W in. So these two can't both be out, and that makes it our right answer. Okay, maximum number of members on the finance committee. This is a really tough question. What you want to do with these is go for the most possible. And if that doesn't work, then you can drop it down, right? So here, like 5, it looks like the most I could ever get is 5 possibly, right? Because at least 2 of these guys, you know, at least one of G or U and one of Z or W has to be out, right? So let's say I put everybody else in, L, M, and H. Well, if H is in, you can see this little chain here. It kicks G out, brings U in, and then kicks L out. So this can't work. So let's try and drop down to 4 and see if that works. I'm not trying to put L in because that kicks 2 people out, both M and U. So let's try putting L out. We'll have H and M in over here. If M's in, that kicks L out. Good, we got that. If H is in, it kicks G out. Yeah, that's fine. Brings U in and then kicks L out. So that works perfectly. This order can work, and thus, you know, we can get 4 in. We couldn't get 5 in, but we can get 4, so C is the right answer. Okay, for 16, we have both M and W on the committee over here, the finance committee, or the inside as we'll call it. So that means you've got this set up here, W and Z, and then Miyuchi's over here. And if M's here, that kicks L out. Now that's already a lot of work, so I just want to see if I've solved the question. What could be true? How about G and L both serve on the finance committee? No, we know L's out, so that's gone. How about G and U both on incentives? G and U can never both be on the same side, so that's gone right away. How about Hawking and Zoo on the finance committee, both in? Again, that's not going to work. We see Z's been kicked out to this side. How about Lep out and Upchurch out? Okay, that looks possible, right? We have U out, G in. Let's just make sure G being in doesn't cause any problems. Okay, it kicks H out, kicks Z out, and puts W in, and we have W in already. So it looks like this works out fine. So that works, and D is our answer here. Okay, for 17, the last one, if Guzman serves on I, so we have G over here, and then U over here, then what must be true? So I'm going to look at U being in, that's going to kick L out, right here. U in, then L out. And G being out does that same thing. It puts U in and then kicks L out. So we can't make a whole lot of inferences here. So I just want to look for this one inference we did make. Okay, LEP serves on incentives is on the outside. Do we see that anywhere? Yeah, we do. It's B, and that's our right answer. So a little bit of an easy question to wrap things up. Okay, that's a game that if you can do that, you've really mastered making chains. It's not easy. So if you have trouble with this game, make sure you come back to it. Make sure you understand how to form biconditionals. That's a very common rule that these two people have to always be apart. So you need to learn how to diagram that in conditional form. Say I said G and U always have to be apart. It's always going to look like this. G, then not U. Arrow works both ways. And then the contrapositive, U, then not G. And remember, these are fully reversible. You know, take this rule. Not G, then U is the same thing. Okay, so that's the game. We'll catch you on the next one. Thanks.